If you've just started web development, trying to figure out the difference between an API and a web application might be a little bit difficult. So let's just break it down to two sentences really quickly. An API is simply a program that responds to HTTP requests, and an application is simply a UI that is placed on top of that API. Quick disclaimer, that's a generalized simplification of API and web application. However, that's outside the scope of this video and we're strictly targeting web development for now, so we're keeping it and we'll clear it up at the end. All right, so let's start with the basics. We have our browser and we want to talk to a server. Well, since we're doing this over a network, the most direct tool that we have built for this is HTTP. And quite literally the browser, what we're calling over here the client, is almost directly built for HTTP. So again, we have our browser. This would be basically where you're running Chrome. And we have a server that we want to talk to. This could be any server. But how is this done? Well, what we have is we have HTTP. And fortunate for us, HTTP has a couple of predefined methods. There are the standardized way for which we communicate across HTTP. Now here's four of them, get, post, put, and delete. You may have heard of these before, or they might be brand new to you. There are others, but these are really the only four that we're going to mention today. Going over all of them is pretty far outside the scope of this video. Maybe we'll do it sometime in the future. The client, I've since switched it to JS, short for JavaScript. This could be the browser. Really what's running in the browser to do all the fancy work that we'll be talking about today is going to be JavaScript. So that's why I've went ahead and switched it out. Now, I've said that an API is a program that responds to HTTP requests, and a web application is just kind of tacking a UI all over that API. And you kind of begin to see that resembled here. We have the client, we're making requests, going to the server. This is happening over HTTP, and we're responding, and the client over here is where that UI happens. So we have the client, it makes a request, the server receives the request, then the server sends a response after it's done some work, and the client receives the response, does some work, and presents the result. So we make a request, receive a request, send a response, receive a response, and then so on and so forth. So where does this server and API talk fit in? Well, let's focus on the server side for now. So this is going to be this side. I'll switch over to a new diagram. So here we've got the server, and I've started to pull some of the details out a little bit. In order for the server to receive the requests that are coming in over HTTP, remember we sent these from some client. In order to receive these requests, it needs to be aware of HTTP and how to talk to it. Which also means it needs to be aware of the various methods that are defined inside of HTTP. Again, we're only talking about these four: get, post, put, and delete. So let's take a second to talk about those. Get is a request whenever we want to specifically get something. We want to get a new resource, or we want to get some information from the server. A post is whenever you want to post something to the server, not necessarily new, it's just a message or information. Put is whenever you want to actually put a new object, or you want to put some new data on the server. Say you're creating a user, or if you're running an e-commerce site and you're creating an order, or if you're creating some new type of data to put onto the server. And delete is kind of self-explanatory, whenever you want to delete something, like deleting a user or deleting any of those examples that we just ran through. Okay, so if we have these HTTP methods, it's kind of starting to sound like we have a standard here. It almost sounds like if you dive into the definition of an API, it kind of sounds like we have an API, but not quite. Again, we're going somewhere with that. Okay, so now I want to talk about how the server actually responds to these HTTP requests. Let's begin to break down a little bit of how that functionality might be built out. So the server needs to be aware of HTTP and needs to be able to accept a GET request. If we have a GET request come in, we would need some method. We need to be able to run some sort of code to receive the request. That request needs to go into our GET response method. We do some work here, and then we would send a response. That's kind of how we've been talking about this. The problem with this is that this means that we have one method for defining what happens for every single GET request that would come into the server. So what this means is that for every GET request, no matter what you want to get, it comes into here. That's beginning to sound like we're kind of muddying the waters with our code, doesn't it? That means that, let's say a URL comes across, it says, I want to get a car. Well, that's pretty straightforward. So we have code, you get response, return a car. Well, we're running a full car dealership website, and so let's say we want to get a different car. Well, now we need to be able to determine which of the two cars to send back. Let's say we have a huge inventory. You have to parse through all of that. You have to parse through pricing. You have to parse through all kinds of things to respond to any GET request. So this is a bad design. How do we answer for that? Now keep in mind, this would be just as bad for post or for put or for delete. It means that no matter how many of these built-in methods that we have, we only have one method to answer with this current implementation. We only have one method on our server to answer for any type of HTTP method that we're passing across from the client. So what do we do? So this is where REST API comes in handy. They offer us a way to organize our server-side code according to what's being requested. So what do I mean by that? You remember how I just said that if an HTTP GET request comes in, we would have to parse what the client is actually wanting to get? Well, REST is a way that it allows us to specify what we're wanting to get directly inside of the request in a very nice way. So you've got this URL that comes across from the client. We're going to say localhost, we want to get something, and we want to get resource 1. Could be anything. This one wants to get resource number 1. So we send the request over, request comes in, the server receives it, and it goes directly here to a very specific method dedicated to getting resource 1, not getting anything, but specifically resource 1. So if there was a resource 2 defined on the server, but the client only said that they want 1, we never even enter this code. So it keeps things secure and it keeps things organized. Now, REST isn't the first attempt to do this. REST is actually still fairly new, even though some would probably call it legacy. This is how they've kept the organization when trying to answer for what people want or want to do through their applications. If you're wondering how all of this fits into the oversimplified definition of an API, well, here it is. The majority of the functionality we've discussed is HTTP communication. Now keep in mind, HTTP has been this thing that is sitting in between our client side and our server side for this entire time. So our communication is following what's called the HTTP protocol. So technically, this is a protocol, not an API, but we're not getting into that just yet. Now this is where the statement kind of falls down. The term REST often gets dropped when discussing this side of web development. So REST would be essentially what's happening here. It's really just the organization scheme for how we're deciding to organize our server-side code. Also, when you're working with a mix of applications, say in an enterprise environment where you've got some applications that are 10, 20, maybe even 30 years old, you've got some applications that are brand new, and also some other web applications that haven't even been written yet, and they're really kind of in a prototype phase. So when you're talking about all these different technologies and all these different applications coming together, a lot of times, whether it's REST or SOAP or GraphQL or anything else, in your normal or your common parlance, the type of API kind of gets dropped off and we just start calling them APIs. We stop caring so much if it's a REST API or SOAP or whatever, and we just call it an API, assuming and understanding that we are communicating over a network or over the internet. So for a plurality of these network systems, HTTP really becomes the standard. Even though it's technically a protocol, we begin to treat it like it's an API because it becomes the standard for how our applications communicate with each other, because we are primarily doing web development and we're creating web applications nowadays. We've kind of largely moved away from a lot of other things. So saying web API is probably more appropriate. All right, it's definitely more appropriate. But all of this responds to HTTP, which is what kind of begins to say that whenever we're trying to quickly delineate what an API from a web app means in this space, we can say an API responds to HTTP requests, and a UI, or the web application, is just the UI on top of it. Okay, so now for web apps. All right, so we're back to having a client, and the client's over here. We're not necessarily connecting it just yet, but that's okay. Previously, we just called this the browser, but now we're actually concerned with what runs inside of it, whether it's React or Angular or Vue or anything else that's not those three, but equally complex, I guess we could say. Basically, some sort of advanced functionality. So I mean, some examples of this would be Gmail or Google Drive, any of your social sites, Facebook, Twitter, TikTok, any of them, but put them out there, or even a lot of e-commerce sites. A lot of those sites, we kind of take them for granted being able to shop online, but a lot of those sites are quite complicated underneath the hood whenever you start thinking about search and responsiveness and being able to handle communication across mobile and web and everything in between. All those sorts of things, each one of them adds a layer of complexity that makes this side of development bigger and bigger and bigger and carry much more weight. But keep in mind, the only thing that we're using to communicate back to the server is this guy in the middle, HTTP. So if we only have the client over here, now this is just JavaScript, we can do a fair amount, but without requesting any data from the server, without ever talking across HTTP, it's kind of pointless for what we can do because we're limited without outside data. So what that leaves us with is that in order to get data or to do almost anything that we would consider useful, we have to make an HTTP request. So nowadays in the more modernized web development, we could be using something called Fetch API. Just like on the server side, you have REST, but you also have SOAP and GraphQL and a bunch of other things. On the client side, what's common nowadays is to use Fetch API, but there's also a bunch of other libraries like Axios, and there's also older technologies like using Ajax via jQuery, or just going straight for a lower level API, kind of similar to an old version of Fetch API called XML HTTP request. Basically, all of these other client-side technologies, they just all they're trying to do is allow you to make an HTTP request from the client side. But again, it's all about code organization and the easiest way or the most efficient way in order to do so. So from here, once we have the Fetch API set up and we make a request, it really gets back to the part that we've already discussed about making a request, receiving them, sending responses, and so on and so forth, carrying on with the communication. So our server is the API now. We have REST API or some other sort of organization scheme. Fetch API, going with that one, is going to allow us to make a request. We receive it. It runs through our code organization scheme, the REST API. So from here, we're really just relying on our backend work. So starting on the client side, we have the Fetch API, which is allowing us to organize our code around making the request, exactly like we've already discussed. We just make the request, it goes over HTTP, we receive it on the server, the request runs through our organization scheme, so it runs through our REST API code, goes into the server, does whatever job we need it to do. Most of the time it's kind of just retrieving data from some database or making some sort of change, then goes back through our REST API code, we send the response, and again, through more code inside of Fetch API, we receive the response and do what we need to inside of the UI or the web application. So like I said, from here, we have all this work happening on the back end, which allows us to just kind of take our UI and just make the request and kind of, again, I'm oversimplifying, but really bolt on an API. And the reason that I keep oversimplifying the front end work here is not to discredit what happens on the front end. It can get fairly complicated on its own, but really your application is the one that is going to determine just how complex this is. You could have something as complex as Gmail, or you could have something as simplistic as just a small to-do app. But even with a to-do app, you still have to have JavaScript and you still have to have some sort of client runtime for that to run inside of the browser. And at a very, very minimum, you still have to be making some sort of HTTP request to a server or to a backend. So the point here is that while each JavaScript implementation, whether it's vanilla JavaScript or any framework, they still allow us to just bolt on a UI. Now this leaves us with our API or web API being the program or server that responds to HTTP requests. And so that would just be this back here. and the web application being the UI in addition to that server. Or if you want to get specific and leave HTTP out of it, that would leave the server and the client. HTTP has already been written. That stays around. It's basically built into the browser and kind of built into the way that we run or do the internet nowadays. So yes, we started with a gross oversimplification of API. Of course, the server does more than just respond to HTTP calls. And yes, a web application is more than just bolting on a UI to all the server-side stuff. However, I did this to highlight the importance of HTTP and the specific role that it plays inside of web development. And this really only cracks the surface. Understanding HTTP and exactly what it's doing, it's those fundamentals. You can write all the JavaScript that you want, and you can do all of the fancy server-side coding that you want. But if you don't understand HTTP, even though it doesn't have some sexy framework built around it, it's still just as important than any JavaScript library or some fancy server-side stuff that you could be doing. Thanks for sticking around. I really hope this helped you understand the difference between APIs and web applications. If you have any comments or questions or suggestions, please leave them down in the comment section down below. If you want to see more explanations like this or more code tutorials, please remember to go ahead and subscribe. And also, all of the plenty of links for all the stuff that we discussed today is also going to be in the description. So if you have any questions or if I mentioned something that you hadn't heard about, yeah, go ahead and drop a question down in the comments for that, and check out the links for everything down below. A lot of it is it's going to be kind of technical, kind of dry, but if you really want to dive into it, there's some good links down there. Otherwise, thanks for sticking around, and I'll see you next time.